Okay, so the first thing that you could do is you could factor the same thing out of each one of the terms. Remember, you can factor a number out of there, or you can factor power of the variable, or like they did in this one, you could factor both. Okay, then we've done this quite a bit. This is a more challenging example than we would really like to start with because there's a 6 in the front. This is like that super long process where you have to go 6 times negative 10 is negative 60. Find two numbers that multiply together to be negative 60 and add to be 11, blah, 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 blah. But yeah, you can do that too. Then we had a couple special cases that we talked about that you don't need to know, but if you can see them, it makes your life a little bit easier. X squared plus 10x plus 25 factors into x plus 5 squared because 5 times 5 is 25 and 5 plus 5 is 10, right? You could switch this around to be negative 10 and then it would be x minus 5 squared because negative 5 times negative 5 is 25 and adds together to be negative 10. So you got that going for you, the old perfect square trinomial. Difference of two squares. 2 squared is 4, x squared is x squared, so you could make this into 2x plus square root of 15, so x minus square root of 15. We got your factoring by grouping, and then this is a little bit of a new one, and we're going to talk a little bit about this, the sum or difference of cubes. So we haven't done that before, but it's a nice little factor pattern that you're going to see just every so once in a while in your life, okay? All right, so let's try some. So let's start with 2x cubed minus 5x squared equals 3x. What do I have to do first? What? Subtract the 3x. Yeah, because all of these things that we just went through, the one thing that they all have in common is you always start by getting them set equal to 0. Okay? All right, what now? Good, so this would be this situation right here, the first one, where you are taking something out of each one of the terms. In this case, Eli says you can take out an x. And if I do that, Eli, what am I left with? Okay, everybody good with that? Yes. Okay, what do I do from there? Sir? Okay, so since this is not 1, we have to go 2 times negative 3 is negative 6. And then you have to say again? Negative 6 and positive 1. Yeah, looking for two numbers that multiply together to be negative 6 and add to be negative 5. Eli says those are negative 6 and 1. So 2x squared minus 6x plus 1x minus 3 equals 0. What happens now? So I can factor 2x out of these first two terms. Love it. Okay, good. So then you break it down into two separate individual problems. So 2x squared minus 6x, you can factor a 2 and an x out of both of those terms. Leaves you with x minus 3. And then this one you can't really factor anything out of x minus 3, but I'm just going to put a 1 in front so that the next step is a little bit easier. Okay, so I still have the x in front. What can I now factor out of these two terms? What do they both have in common? An x minus 3. So I'm going to factor out that x minus 3. If I factor an x minus 3 out of here, what's left? If I take this x minus 3 away, what's left? 2x. And if I take this x minus 3 away, what's left from there? Plus 1. Okay, equals 0. So that is it in its completely factored form. So that tells us that there are 3 answers because there are 3 pieces. What makes this equal to 0? 0. What makes this equal to 0? 3, and then this is the tricky one. What makes that equal to 0? Negative 1/2. Some of you said 1/2, some of you said 0.5, but it has to be negative 1/2. Okay? Good game. Can we go home? No, the game has only begun. All right. Love it. Kate doesn't even wait. I can't, Max, because Kate has started already. You take out a what? More than an x? What? X squared, yeah. And then what number? What number? Right. Okay, so do you guys see that 3 goes into 3, 6, and 12 evenly? And then also you can take an x squared out of all of them because they each have at least x squared. So this is what? X squared. Uh-huh. Uh-huh. Plus 4. No x because we factored it out. Okay? It's the Kate Klinger Show. All right, keep going. Oh, all right. You have certainly done enough on this problem. All right, so now we have to factor x squared minus 2x plus 4. This one does not have a number other than 1 in front of the x squared, so it's easy. We just put an x and an x in front. Now I need 2 numbers that multiply together to equal positive 4 and add to be negative 2. Negative 2 times negative 2 is positive 4, but negative 2 plus negative 2 is not negative 2. The only other numbers that multiply together to be 4 are 4 and 1, and you can't get a 2 out of that. So that means it does not factor. So that means Tehran, everyone's best friend. The quadratic formula. Okay? So going back up to this part right here, A is what? B is, and C is. Okay, so then if you look at the formula on the wall there, we're going to do the opposite of B, good, which is 2. Yep. Which is, 4. Right, times A times C, all divided by 2. Okay, okay. Thank you, Kate. Once again, nice job. All right, so if I go 4 times 4, I get 16. 4 take away 16 is negative 12. So normally you would stop there and say, can't take the square root of negative number. No solution. But if you go back and look at the directions, it specifically says what are the real or imaginary. So that means imaginary numbers are allowed. So take the square root of negative 12 and break it down. What's the number that goes into? Okay, good. So we know the square root of negative 4. So I'm going to rewrite it as negative 4 times 3. So this is 2. Yeah, 2 plus or minus. What's the square root of negative 4? 2i. Beautiful. And then we don't know the square root of 3, so that stays in there. Still have a 2 underneath. All of the numbers outside of the square root are divisible by 2. So I'm going to do it. I'm going to divide them all by 2. So that's 1 plus or minus 1i times the square root of 3, technically over 1. Okay? So this equation actually has 4 solutions. Yeah. What's one of the answers to this equation? Nice. So Eli goes back all the way to here, and we did factor out that 3x squared, right? And so we know that this has to equal 0 for this times this to be 0. So one of the answers is 0. Since this is an x squared, what's another answer? Or I should say, how many times does 0 come up? Twice. So this gives us two answers that are both 0. Then from down here, you get 1 plus I times the square root of 3, and you get 1 minus I times the square root of 3. So there are our 4 solutions. Okay, Kat? Yes, yes, you're absolutely right. We probably should have written just x equals 0 and then said multiplicity of 2. Yeah. Sub you out? No subs. Yeah, so that's what Kat was saying, is that we probably should have just gone like this and said multiplicity 2. That comes up twice. But it is important to know that that's a multiple 0 because that does affect the shape of the graph, which will be important later in your life. Okay? But see, that's the thing. I do. I've been to the future. I've been to the future. I've seen your life. Okay, so here we go. It's the Kate Klinger show once again. Minus 4. Okay, good job. Okay, we got a trinomial here, right? Can we factor anything out of all three terms? We can factor out of 1, but that won't change the problem. No, there's no number that goes into 1, 3, and 4 evenly aside from 1. This doesn't have any x's, so we can't factor any x's out of there. So we're going to go to the double bubble situation. In order for the first two things to multiply together to be x to the fourth, what do they have to be? What two things multiply together to be x to the fourth? No, I'm not looking at this number right here. I'm looking at these two numbers right here. Nice. That's what I was trying to get you guys to figure out. Normally, that's just an x and an x because we're trying to multiply them together to get an x squared. But this time, since we're trying to multiply them together to get an x to the fourth, they're going to be an x squared and an x squared. Does that make sense? Okay, now we tackle this the way we always have. Two numbers that multiply, negative 4 and plus 1, because negative 4 times 1 is negative 4, and negative 4 plus 1 is negative 3. Okay? So that means that each one of those separate pieces has to equal 0, right? So now I have two new, much simpler equations to solve. One is x squared minus 4 equals 0, and the other one is x squared plus 1 equals 0. What do you get from this one? Or what? Negative 2, yeah. So you can think your way through that. You know that 2 times 2 is 4. You know that negative 2 times negative 2 is also 4. Or if you want to, you could recognize that this is the difference of two squares. So this factors into x plus 2 times x minus 2, which means that x could equal 2 or x could equal negative 2. Okay? You can just see it if you want. I'm just kind of showing if you can't see that, that's where that comes from. Okay, this one does not factor. Right, and so to solve this one, we would subtract 1 from both sides. Then how do I get rid of the squared? Square root it. And what is the square root of negative 1? What is the square root of negative 1? I. Which again, we only include because it specifically says that imaginary solutions are okay. If it doesn't say that, then for that part we would just throw it out. Okay? So this one also has 4 answers. X could equal 2, x could equal negative 2, x could equal I, or it could equal negative I. Right? Exactly. It's weird that Jimmy wants to be done. I'm surprised that you guys aren't wishing that you could stay in this classroom all day and learn math, okay? All right, so here we go. Will you guys take out the printed piece of paper that I gave you at the beginning of class, and let's look at the bottom part that says sum or difference of two cubes, okay? To start with, we're going to do, we're going to go Kate Klinger, and we're going to set it equal to 0, okay? If you look at that piece of paper that I gave you, it has the difference of two cubes, and it says a cubed minus b cubed is equal to a, what? Wasn't it, if it's a cubed minus b cubed, isn't it? Okay. Uh-huh. Okay. So this is our factor pattern for adding or subtracting two things that are being cubed, okay? So in this case over here, if I'm looking to factor x cubed minus 1, what does a equal? How can I make this look like this? A equals x, and then b equals 1. But 7 is not a perfect cube, and so then if it did equal 7, we couldn't use this, okay? So I'm going to rewrite this thing right here. But instead of writing a, I'm going to write x. And instead of writing b, I'm going to write 1. Yeah. Absolutely. But you're missing out on two solutions if you do that. Okay? There are two more solutions. Okay, so I'm going to just rewrite that stuff over there. So I'm going to go, yeah, x minus 1, x squared, plus, yeah, if I multiply a times b together, in this case, I just get x, and then 1 squared is just 1, okay? And that equals 0, okay? And I believe that Jimmy and Kate, right from the beginning, when we see x cubed equals 1, we're like, well, obviously x just equals 1. That's this piece right here, right? If x minus 1 equals 0, then one of our solutions is that x equals 1. However, we have more because now we can mess around with x squared plus x plus 1. But wait, there's more, if you call now. Okay, two numbers that multiply together to be 1 and add to be 1. 1 times 1 is 1 plus 1, 1? No, so this will not factor. And when you're using this factor pattern, this thing right here will never factor. Not yet, because what do we have to do if we have something that can't factor? We have another, yeah, good. We can use the quadratic formula instead. In this case, a is 1, b is 1, and c is 1. Okay, so to use the quadratic formula, I go minus 1, okay? Mm-hmm. Okay. Awesome. All right, so now we use the quadratic formula. Right, and then I get negative 3 underneath the square root. What's the square root of negative 3? Right, we just have to do the I. So it's negative 1 plus or minus I root 3 over 2. Okay? So when you looked at x cubed equals 1 and you said, duh, x equals 1, you're right. But you only got one of the three answers. One of the answers is that x equals 1. One of the answers is that x equals negative 1 plus I root 3 over 2. And the other one is x equals negative 1 minus I root 3 over 2. Okay? I just have to say how pleased I am with some of you in class and the progress that you're making. It's just really encouraging. Yes? How are you what? Oh, everything that's taught in this class is taught for 3 reasons, okay? Reason number 1, it's on the state test that you have to pass in order to graduate. Reason number 2, it's on the college placement test that you have to take in order to get into a math class in college. Reason number 3, it's used in a future math class, okay? So I know that that's not as satisfying as saying you will use this every time you do laundry after the age of 40. And you go, oh, I love doing laundry. I really need to learn how to factor, but it's not that simple. I can't give you that. That is a lie. That is a lie. I know you don't have to, but for you with that math brain that you have to not take a math class next year would be a complete and total waste. Yes, you will. You, go back. No, no. You're going to take math analysis next year with me. You'll exactly. So you already know how to do it. Easy A. Yeah. That's what I'm saying. Why